Alright, so let's do a few practice problems on walk energy and power. So a 4 kilogram ball was dropped from a height of 100 meters. Find the velocity of the ball just before hitting the ground. Okay, so how does it work? Okay, so we need to find the velocity. So we know the velocity can be found from kinetic energy, which is half mv squared. But then we don't know kinetic energy. But by conservation of energy, we know that potential energy at the top is equals to kinetic energy at the bottom. Because why? Let's say this is ground, right? So the ball will be 100 meter above ground. Okay, and this is 4 kilogram. So the potential energy at the top will be equals to the kinetic energy at the bottom. That's why. So potential energy is mgh and kinetic energy will be half mv squared. So you don't even need to actually use mass. So mass, you can cross it out. So v squared is equals to 2gh. So v is equals to square root of 2gh. Square root of 2 into g is 10. Your height is how much? 100. Alright, so your final answer should be 44.7 meters per second. Okay, so pause the video to read the question first, okay, before you look at my walking. Alright, so the skier starts from T, okay, so with the gravity he goes down and then he reaches point B. At point B, his kinetic energy is this much. So state the gravitational potential energy, okay, potential energy at T. So as I mentioned before, okay, kinetic energy at the bottom is equals to your potential energy at the top. So your answer here, right? So your potential energy is simply 5.5 into 10 to the power 4 joules. So the skier stops at point B due to friction. So he's going to slide over here, right? But then there'll be friction. State the relationship between walk done, force, and distance moved. Very simple. W is equals to F into D. Calculate the mean frictional force as the skier moves from B to P. So we already know our walk done here. Okay, at point B, the energy is how much? The kinetic energy is 5.5 into 10 power 4. And that's why your answer should be F is equals to W by T. From rearranging the equation, you get 1 mark. So your walk done is 5.5 into 10 to the power 4 divided by the distance, which is from B to P. How much? It's 73, right? So 5.5 into 10 power 4 divided by 73, you should get 750 newtons. 750, the unit is newtons, okay? So that is the frictional force, okay? Which is going to act in this way. Alright. The diagram shows a ball of dough, which is a mass of 580 gram held at 92 centimeter above the floor. Calculate the increase in potential energy when it is above the floor. Now a trick here is PE is equals to mgh. From writing this, you get 1 mark, okay? Now take a look at this. This is grams, this is centimeter. So you can't simply substitute it here, okay? So what you have to do is 580 gram will be equals to 0.58 kilograms. Your G is 10. Your height shouldn't be 92 centimeter, it should be 0.92 meters. So put that into calculator and you will get 5.34 joules. Okay, so they already mentioned they want joules here. Okay, 5.34 joules. Notice that you needed to change gram into kilogram and centimeters into meters. Okay, all right. So from here you get 1 mark. From changing the units, you get another mark. from getting the correct answer, you get the final marks. Okay, so you get a total of 3 here. So the ball of dough hits the floor and it doesn't rebound, meaning that when it hits, it just stop right there. So describe the energy transfers taking place, okay, after it has hit the floor. You should refer to energy stores as well as energy transfer. So before the dough is dropped, right? Before the dough is dropped, it is in above the ground at 92, meaning that, sorry. Okay, so these 4 facts are what you should be talking about, okay? So initially, right, the dough, because it has a height here, okay, it will have the gravitational potential energy, okay, and your normal potential energy, which is caused by your gravity, okay, so you have the gravitational potential energy, and it says just before the dough hits, right? So just before the dough hits the floor, right, it's going to have more kinetic energy than potential energy, because remember, kinetic energy at the bottom is larger than the gravitational potential energy at the top. Now, when the dough has actually hit the floor, right, the kinetic energy becomes 0, okay, because it's going to stop. And also, your energy will be, okay, transferred to the surroundings or the floor as heat energy, mechanically and by radiation, okay. From answering these facts, you should get 4. So by right, you should at least get this, such as it has potential energy. Before it hits the floor, it has more kinetic energy than potential energy, or you can say that it has maximum kinetic energy. So when it hits the floor, the kinetic energy is 0. By right, 3 of these, you should get it. So the last one might be difficult for you, but energy is transferred to the surroundings as heat energy. Alright? Alright, so let's take a look at this one. Pause the video again to actually read the question. Okay, so let's take a look at this, okay? After falling to position X, 1.25 10 to the power 3 kilogram of water has this amount of energy in kinetic store. Calculate the speed of the water at position X. So this is very simple, okay? So kinetic energy KE is equals to half mv squared, okay? So you're going to change this equation first. So v squared is equals to 2ke divided by m. So your v would be square root of 2ke over m. So by rearranging equation, you get 1 mark. So v again is equals to 2 into kinetic energy. So this is 3.2 into 10 to the power 5 divided by your total mass, which is the mass of the water here that has dropped down, okay? 1.25 into 10 to the power 3. Put that into calculator and you should get, let's see, 22.63, okay, meters per second. Alright, so question B, water with a mass of this mass, same mass, okay, is going to fall through 45 meter from upper lake to the turbine here, okay. So the height is 45 meter. They're going to ask you to calculate the decrease in potential energy between upper lake and turbine. So fairly simple, okay. So potential energy is equals to mgh. So your mass is how much? 1.25 into 10 to the power 3. Your G is 10 and your H is how much? It's 45 meter between tunnel and turbine, okay? Alright, so put that into calculator again and you should get 562,500 joules, okay? So state how much work has been done on the water by Earth. This is just a trick question. It means what? Work has been done on the water by Earth, right? So Earth has what? Earth has gravity. So it's just asking about the gravitational potential energy. So your answer here is going to be the same, which is 562,500 joules, okay? So state the method of energy transfer required for this work to be done. So the energy transfer, right, since it is by mechanical means, you can just say mechanically. This is a mechanical transfer of energy, so from this you get 1 mark. Very simple. Alright, a student uses this apparatus to investigate the force needed to pull a block along a ramp. State the formula linking walk done, force and distance moved. Fairly simple. This is W is equals to F into D. The student pulls the block 0.89 meter along the ramp by using a force of 26 newtons. Show that the walk done on the block is about 23. So W is equals to your force is how much? 26. And the distance is 0.89. Put that into calculator. You should get 23.14. Okay, so which is approximately equals to 23 newtons as they want you to show here. Now the block has a mass of 1.3 kilogram and moves vertically 0.11 meter. Okay, so calculate the increase in gravitational potential energy of the block between the bottom and the top of the ramp. So you really don't need to do anything. So potential energy is simply mgh. So from this you get 1 mark again. So mass is 1.3 kilograms. Since it's kilograms, you don't need to change anything. G is 10. H is 0.11 meter, because the height that is being taken is 0.11. So from this you get your second mark. Alright, so put that into calculator and you will get 1.43 joules. Okay? Explain why the work done to move the block along the ramp is greater than the increase in the GPE store of the block. So when you're pulling it like this, right, that is the work that you calculated here, which is 23, but the potential energy is just 1.4. So why is dragging this requires a lot more work? Okay, so it's giving you 2 marks, so there must be 2 reasons. First of all, it's because this ramp, right, it has a friction. So you can say that it is because of friction. Alright, so another mark, right? It's because your energy right here, okay, is transferred to the surroundings mechanically. Because when you're pulling it, right, so you'll be losing some other energy as well. Okay? Energy is transferred to surroundings. Okay, mechanically. That's why. Okay? Now the student suggests, okay, 1 mark here, 1 mark here. The student suggests it's better to use a less steep ramp to raise the block to the same vertical height. So what the student is suggesting that instead of this, right, we should use, let's say, a longer ramp, okay, to raise the block to the same vertical height, less steep. Okay, discuss one advantage and one disadvantage. So just draw a very rough diagram here how it will look like. Okay, so if I draw a less steep ramp, right, let me draw it here. All right, so to get to the same potential height, okay, to get to the same height, I need a longer ramp. Okay, so let's see what's the advantage first. Okay, so the advantage is that we only require a lower force. Okay, because we can spend some time. Okay, so we only need a lower force and it's easier to move the block. Okay, but the disadvantage is that a longer distance ramp is required. Okay, meaning that you have to put in more work. Okay, so by answering these you will get 4 marks from here. Okay, so again, to answer these questions you have to think very logically, okay, and then write down your explanations very clearly. And if you're given 4 marks, always make sure that you have 4 distinct points that they can give you marks for. Okay, all right, last one. The photograph shows a truck with a crane that is used to move large bags of building materials. State the formula linking work done, force and distance moved. W is equals to force into distance. A bag of building materials has a weight of 8750 newtons. So weight, right? You should know that weight is equals to your force, which is 8750 newtons. Calculate the work done on the bag when it is lifted a vertical distance of 230 centimeter from the ground. So your displacement is your vertical distance, right? Is your D, which is 230 centimeter. Alright, so we can have it at centimeters, so it's going to be 2.3 meters. So calculate the work done. W is equals to question mark. Okay, so your W is equals to W is equals to F into D, okay, is equals to 8750 into your distance is 2.3. So in the calculator, if you put it in, you should get 20125. The unit for it will be joules here. So you might be wondering, oh, this is height, right? Why don't we use mgh? It's the same thing. If you use W is equals to mgh, right? So mass into acceleration due to gravity. This is simply your weight, okay? This is your walk. This is your weight, okay? Don't confuse. W is equals to mg, right? How much is it given? It's equals to your F, okay? So your weight is your force, 8750. So this will be 8750 into your height, which is 2.3. So you'll be getting the same answer nonetheless, okay? So the crane takes 7 seconds to lift the bag. Calculate the mean power output of the crane when it is lifting the bag. So we know that our work done is 20125 joules, okay? And the time taken T is 7 seconds. So your power is equals to W over T. So your W is 20125, and you're going to lift, you can lift it in 7 seconds. So your power would be 2875. Unit is watt here, so it's watt. So those are the practice problems for power, work, and energy. Should you find any more practice questions, please practice on your own again. Alright, so see you guys next time. Bye bye.